Hello everyone, my name is Harsh and in this video I am going to explain a research article on topic current trends in surface plasmon resonance sensor technology. This review explores the development of surface plasmon resonance sensor and benefits of LOC, demonstrating how surface roughness can increase in sensitivity and review also highlight the application of dielectric layer application and multi-layer graphene and polymer coating. Introduction. LOC, Lab on a Chip technology, reduce, reduces sample volume, automation, and measurement time. Lab on Chip technology is a modern approach to analytical devices development integrating laboratory functions on one chip. And this technology can also help in reducing sample volume, automation, and measurement technology. Optical methods such as refractometric methods based on surface plasmon resonance can offer high accuracy and sensitivity. SPR also uses chemical and biological analysis for real-time analyze for real-time modular interaction. The SPR sensors consist of sensitive layers that provide a selective response. The characteristics of this sensitive element can be optimized through construction, manufacturing, technology, and material choices. SPR, or surface plasmon resonance, is a phenomena where light at specific angle of incident which results in the excitation of conduction electrons in the thin metal film. For example, here we have used golden film. This phenomena mostly occurs in metal with high electrical conductivity and chemical passivity. Here we have used golden film at which the light is reflected and detected by the detector, and this detection can be observed through the intensity and the angle at which the light has reflected, which results in the resonance signal change in the resonance signal. Core principle of SPR. Firstly, we have resonance angle, observed as a sharp drop in the light intensity at specific angle due to plasmon excitation in thin films. Secondly, we have Krenschmann geometry, which invokes a prism and metal dielectric waveguide film to provide total internal reflection. Krenschmann's configuration uses a thin film which is placed on a di-layer substrate, and the light is incident through this di-layer film, allowing SPR to be excited at the metal interface. And third, we have reflection curve, determines the analysis refractive index by absorbing shift in the reflection curve. Mechanism of SPR sensors. Resonance phenomena. Resonance phenomena is nothing but the vibration of the metal film when hit by the light intensity, and this is how basically SPR works. L, PCL, which plasmon carrying layer. PCL, a plasmon carrying layer, is the layer which observes the drop of reflected light intensity at specific angle. This layer is typically made up of gold and silver. The most common method of excitation is for this layer is coupling prism method. Coupling prism method invokes two geometries, Krenschmann's and Otto's geometries used for SPR excitation. The most common, it is one of the most common methods. The Otto configuration involves a prism and a thin metal film separated by a thin air gap where light enters the prism and reflects off the metal surface, generating SPR. Reflection curve analysis. Reflection curve analysis is basically the shift in the reflection curve indicating the change in the refractive index. Innovative materials and approaches. First is graphene coating. Incorporation of graphene for enhanced electrical properties and sensitivity. The gold layer is one of the most widely used surface plasmon. For this layer, however, copper and aluminum are not used due to their electrical properties and sensitivity, as they widens the reflection gap. Nanoparticle enhancements. Silver and gold particles improve sensor response and surface interaction. As therefore, silver nanoparticles to gold surfaces are applied using self-assembled monolayer. The gold and silver are the most commonly used surface electrodes material due to their high oxidation capacity and high dielectric permeability. Polymer layer. The use of polymer layer, namely high frequency plasma polymerization to increase sensitivity. Waveguide optic fiber. Optic fiber with narrow geometries and dielectric layer in, increases sensitivity, from which we can understand that how important is it to choose the optimal metal and light frequency is crucial for achieving maximum sensitivity and chemical intent, inertness of S- SE, that are surface electrode surfaces. And we can also use porous dye layer that can also help in the further increase in sensitivity of the surface. Technical advancement. Thermal annealing. 120 degrees Celsius is the mm, most preferred temperature for annealing of these surfaces, as it reduces surface roughness, enhances, which in turn enhances sensor sensitivity and stability. Deposition technology. Technology. Now, this surface roughness influences the deposition speed and angle during the layer formation, improving the sensor performance. Now, this sensor can be based on gold film covered with aluminum oxide, titanium oxide, silicon oxide, and zinc oxide, which has high which has high sensitivity and accuracy to lower detection limits. Example of SPR devices, notable models and their function features. Plasmon series. Models like Plasmon 6, Plasmon 7, and Plasmon 9 design are designed for diverse application and high sensitivity measurement. Advanced capabilities like we have discussed before, LOC. LOC, uh, Lab on Chip technology, is an automation technology which can give features like autonomous operation to devices, in turn leading them to lose some weight and get into a modular design. Silver nanoparticle on gold surfaces can be applied using self-assembled monolayer, giving them a more boost in the sensitivity. Sensors with sensitive elements like this are typically located on glass substrates. but polymer substrate may be more promising for biosensor surface modification, enhancing SPR sensor performance methods to improve sensitivity and accuracy. Surface roughness decreases the roughness, enhancing plasmon propagation and sensor response. Now, increase in this surface roughness can lead in the widening of reflection characteristic, leading to an error and affecting the shape of dispersion curve and the frequency resonance frequency of the surface. Layer composition. Use of porous nanostructured coating, additional layers and typical material and optimal material selection. Now these additional layers can be used to reduce mutual inference between this sensor surface and sensitive elements are covered with an inner protective layers. Innovative coatings. Graphene and polymer layers, namely high performance plasma polymerization for added stability. So in conclusion, we know that surface plasmon resonance works, how surface plasmon resonance works, its mechanism, methods used in it, and the benefit of LOC. We also know and learned about dielectric layer, nanoparticles, self-assembled monolayers of nanoparticles like silver on gold surfaces, and about the multi-layer graphene and polymer coating, which provide protection and stability to these sensors. These are some references from the from this research article. Thank you.